Okay, so we are at our day of reviewing and all our functions. This is such an exciting day. So we first start with our linear functions, right? Our lines, and we have our parent graph of a line, which is y equals x. We know that domain is all real numbers, range is all real numbers. Notice I toggle back and forth between y equals and f of x equals, which we know is the same thing as like y equals 3x minus 2. We know this starts by a y-intercept of down 2 and then up 3 over 1 for the slope. So similarly, domain and range is all real numbers. And really the domain and range of all lines is always all real numbers except for our horizontal line, so y equals 1. Here, now we have a domain of all real numbers, but the range is just 1. And a vertical line like x equals 3, now the domain is just 3 and the range is all real numbers. So that kind of covers our linear functions. Quadratic functions, we know the parent graph is just this u with a vertex at 0, 0. We know the domain is all real numbers, but now the range, all the y values are greater than or equal to 0. Notice I changed it to function notation, and this is when we learned our shifting patterns. This one goes up 2, so vertex is 0, 2. Domain is still all real numbers, but now the range is greater than or equal to 2. Here, when it's on the inside, the shifting happens right and left. This one goes left 2, so vertex is negative 2, 0. Range is all real numbers, or sorry, domain all real numbers, range greater than or equal to 0. And then here's our kind of combo where it goes right 2, up 1, and then it's upside down. So the vertex here is 2, 1. Domain is all real numbers, and the range is less than or equal to 1. So in quadratic functions, the domain is always all real numbers, and the range depends on the vertex. Polynomial functions, here's where we're really going to depend on our graphing calculator. We can tell certain things like the roots. This one has a triple root at 2. Remember, triple roots go through. Domain and range are both all real numbers. This, by the way, is when we also introduced end behavior, so I'm just going to add that in here. As x gets big or goes to infinity, the y gets big. And on the other end, as x gets small, the y also gets small. In other words, it's going down. One like number 10, I'm going to have to use my graphing calculator to help me with that. So this is going to go have roots at negative 2, positive 3, positive 4, negative 2, 3, 4. And I know the domain is all real numbers. Then this one here, let's see. I'm going to put this in my graphing calculator so I can see it. And I can see that it's got this classic like up, down, up type of thing. Right? So domain and range are both all real numbers. And for these purposes, we're just really concerned with the roots. When I see a negative, though, on the outside here, this is going to tell me that this is going to kind of go downhill. So I have a double root at negative 2, that's going to bounce, and a positive root at 1. I'm typing this into my graphing calculator here. A second. Right, so this one's going to kind of come down here, bounce, it's going to go back up, and then down. So this is all real numbers, all real numbers. To go back to that end behavior again, how this is different. So back in number 10, as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. Here it's a little bit different. As the x goes to negative infinity, the y goes to infinity because it's getting bigger. And here as x goes to positive infinity, y goes to negative infinity. Last one. And again, I'm doing this on a graphing calculator to see. So I see again that negative sign and how that's going to go downhill. Now I've got this triple root at 3. So, sorry, triple root at 2, 2, 2, 2. So triple roots go through. This has got this negative, so it's going to come down like this. All real numbers, all real numbers. And again, if I wanted to do the end behavior, as x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to negative infinity. Polynomial functions. Then we moved on to rational functions. So here's where we started getting asymptotes, right? Or what we call the dotted plus sign. So there's things that x is not allowed to be. So like on the domain side, x is not allowed to be 0. That gives me a vertical asymptote at 0. Horizontally, the y is not allowed to be 0, so a horizontal asymptote at 0. And then we're going to take that graph, we're going to go up, down, right, left. Here it's going to go right 3. I like to just take the dotted plus sign and take the dotted plus sign right 3. And then I can fill in my asymptotes here. The vertical asymptote is at x equals 3, so that means the domain is not allowed to be 3, right, because that would make the denominator 0, and the range is not allowed to be 0. And then I can just fill in my swoops like that. 1 over x plus 2, this one's going to go up 2. So I'm going to take my dotted plus sign, and I'm just going to move it up 2. Like that. So this means my vertical asymptote is at 0, x must not be allowed to be 0. My horizontal asymptote is at 2, y is not allowed to be 2. And then I can fill in my swoops. And then here, the next one, this is kind of a combo where it goes left 3 and down 1. So left 3, down 1. So this means my vertical asymptote is at negative 3, x is not allowed to be negative 3, horizontal, just horizontal asymptote is equal to negative 1, and so the range is not allowed to be negative 1. I know that's tricky, and then we can get the swoops in there. So those were our harder rational functions. Then we moved on to radical functions, and now this I think is worth pointing out that it's understood to be positive, so it's just that arc of the graph. So the domain here is greater than or equal to 0, as is the range. If I go down 2, the domain is still greater than or equal to 0, but now the range is greater than or equal to negative 2. If I go right 1, the domain is greater than or equal to 1, range is greater than or equal to 0. And then here I'm going to go right 4, up 2, like that. So the domain is greater than or equal to 4, the range is greater than or equal to 2. Then we got to exponential functions. These are going through the point 0, 1. So there's a horizontal asymptote at 0. All real numbers. Careful, the range is greater than 0, not greater than or equal to 0. If we go up 1, now my asymptote kind of also goes up 1. So my horizontal asymptote is at 1. Domain is still all real numbers. Now its y is greater than, not greater than or equal to, but just greater than 1. Here, this is going to go right 1. So instead of at 0, 1, it's going to get 1, 1 here. So the horizontal asymptote is still 0, domain is still all real numbers, still greater than 0. And then this is your combo where it's like left 1, down 2. So the horizontal asymptote comes down 2 to negative 2. There's my graph, all real numbers, greater than negative 2. Log functions, log base 2 of x, remember that this is the same as 2 to the y equals x. And so what we said is that it's really the inverse of this function. So sometimes I draw that function, then do the inverses. If I change colors, so instead of 0, 1, it's at 1, 0. Instead of 1, 2, it's at 2, 1. Instead of 2, 4, we're at 4, 2. And that kind of helps me get that graph how it hugs. So now it has a vertical asymptote at 0. The domain is greater than 0, and the range is all real numbers. If I take that graph and I go, this is going to be down 1. So I'm going to take that point kind of down 1, like this. So still vertical asymptote at 0, still all real numbers, still greater than 0. But when I take it, this one's going to go left 2. So again, I'm taking my point 0, 1 and going left 2, and I'm taking my asymptote, which was the x-axis, and taking that left 2. So it's going to be like that. So the vertical asymptote would be at negative 2. Domain is all real numbers. The range is, I just messed that up, didn't I? The domain is greater than negative 2, and the range is all real numbers. And I messed that up over here, too. This one should have been x is greater than 0, and then all real numbers. Sorry about that. Last one is going to go right 2, up 3. So if, again, I take my 0, 1, or 1, 0, and I take that right 2, up 3, it's going to be like there. Do it there. And then the asymptote is just really going to move right 2. The asymptote doesn't really move up and down, so again, now that's x equals 2, so x is greater than 2, and all real numbers. And it could just fill in like that. Oops, kind of goes a little bit more like that. Log function. I like these just a graph functions. It's really reinforcing the difference with the dots versus like connected graphs. So if it's just the dots, you're just really listing the x values of those dots. So the domain here would be -2, 0, 2, 3, where the range is the y values like this. So the y values would be 1, 2, 3, -3, -1, 2, and 3. When it's connected, this looks like it's going kind of forever in both directions. I don't really see any restrictions, all real numbers, all real numbers. Here the domain is between -3 and 3, and the range just looks like it goes up to 4 from 0, so it's between 0 and 4 inclusive. And again, when it's zigzagging the other way, that's all real numbers, all real numbers. This last section gives you some ordered pairs, and then you have to decide what's the equation that goes with those ordered pairs, and what kind of equation it is. So I like to graph them first. -1, -1, 0, 1, 1, 1, 2, 3. So 2, 5. This looks to me like a line, so I would say it's a linear equation. Y-intercept looks like 1, and the slope looks like, isn't it, 2, so y equals 2x plus 1. Or I could even better say f of x equals 2x plus 1. So then this one here is probably not going to be linear. Let's see, -2, 5, -1, 2, 0, 1, 1, 2. Okay, this looks to me like a quadratic. And the quadratic is moved up 1, so it's f of x equals x squared plus 1. Here I've got -1, 1/3, 0, 1, 1, 1, 2, 3, 2, 9. Okay, I can tell that this is an exponential function, and it looks like it's y equals, or f of x equals 3 to the x. Last one here, 0, 0. Let's see what this one's going to be. 0, 0, 1, 1. 1, -1, 4, 2, 4, -2. This is this sideways parabola. This is actually a radical function, and it's plus or minus. So it's y equals, or f of x equals, plus or minus root x. That one's kind of a hard one. I like this last question where it has some matching. So the exponential equation goes with a, 2 to the x, and then that goes with graph k, 2 to the x. Or here, the linear equation, or the line, goes with e, y to the x, and then it goes with graph g. So each equation, quadratic, is b, y equals x squared. That goes with the graph h. The radical function is d. That goes with the graph j. And then the last one is the rational function, which is c, which goes with the graph I. So there we have it, the review of all the functions that we've learned.